Hey, welcome back to another one. Today we are doing Chapter 5, Lesson 5. This is 6th grade math, and today we're comparing and ordering rational numbers. We're going to go ahead and start off with the real world link. Here we have links of several common types of insects shown in this table. Which of the insects is the longest? And then it also wants us to shade each fraction strip to represent the lengths of a fire ant and a housefly, which is longer the fire ant or the housefly. So this is going to go back to some stuff that we've already learned. Oh, that's the one. So here is our table. We have 3/4, 1/1, 1/3, 3/4, 1/4, 1/2, and 5/8. Now, typically when we need to compare fractions, we need to make sure that the denominator is all the same. In this case, the first question is asking us which of the insects is longest. We do not need to compare any of the denominators or change any denominators. There is an obvious winner here, and that is the cricket being 1 inch long. All of these other measurements are all actual fractions. Therefore, none of them are bigger than 1 or even close to 1. So therefore, cricket is the longest in that question. If for any reason we did not have a clear answer, we would then need to compare each fraction by changing the denominators to be something common. For example, if I wanted to check between the green June beetle and the mosquito, I would have 3/4 compared to 5/8. I would need the denominators to be the same in order to compare them. I can make 4 become 8 by multiplying it by 2. All I need to do is multiply the numerator by 2 as well. This will make 6/8. So the June beetle is going to be 6/8 of an inch. The mosquito is 5/8 of an inch. Therefore, the June beetle would be the longer insect if I were to compare those two. But again, since the cricket was 1 full inch, I did not need to compare compared to the other ones because they were all still proper fractions. Moving on to number 2. Shade each fraction strip to represent the lengths of a fire ant and a housefly. Fire ant being right there at 1/3, and a housefly, which is right here at 1/4. Now, our strips have already been broken down. We see this one whole strip representing an inch broken into thirds. 1, 2, 3. Our fire ant represents one of those thirds. So I'm just going to shade it in green since we highlighted fire ant in green. So my fire ant is this long, 1/3 of an inch long. The housefly is also represented here with a whole inch broken into fourths. 1, 2, 3, 4. The housefly represents one of these fourths, which is right here. Using this strip, I can compare that 1/3 is bigger than 1/4 because of this extra space right here. Therefore, the fire ant is longer than the housefly. If for any reason the housefly had been 2/4 or 1/2, it would have been this long and been longer than the fire ant. This is a way to be able to compare without having to change the denominators of 1/4 and 1/3. Because if we were to compare these without doing a chart, I would need to change their denominators to be something common. I know that I can't turn 4 to 3 or 3 to 4, but I know that I can make these into something that both of them go into just by multiplying them by each other. And then remember, you need to do the same up here. So 1/4 would become 3/12, and 1/3 would become 4/12, meaning 1/3 is slightly bigger than 1/4. How many of the insects are longer than 0.5 inch? So that means how many of them are bigger than a half? we're going to go ahead and make this a little bit bigger so we can see. So an easy way to do this is to check the denominator first. If our denominator is 4, for it to be a half or bigger, and this says longer than 1/2, this needs to be bigger than a 2, which it is. So the June beetle is bigger than a half. The cricket, obviously bigger than a half because it is a whole inch. Now, we're going to recall our old notes here because we talked about certain fractions. 1/3 is the same thing as saying 0.3333333 forever. So this is not going to be bigger than a half. 3/4 shows up again with the firefly, which we already confirmed up here with the green June beetle is bigger than a half. That is actually 0.75. Housefly is 1/4, which is 0.25, so not bigger than a half. So we're going to cross that one out. The Japanese beetle is a half, but we need to look at our question carefully. It asks how many insects are longer than 0.5 inches or half an inch. This is exactly half an inch, so it is not longer. So we're going to cross that one out. And then finally, mosquito is 5/8. Again, half of 8. We look at the denominator. Half of 8 would equal 4. So it needs to be any number bigger than 4. And since 5 is bigger than 4, mosquito will count as well. So the insects that are longer than half an inch are as follows: green June beetle, cricket, firefly, and mosquito. Therefore, there are 4 insects that are longer than 0.5 inches. Order the lengths of a housefly, a green June beetle, and a fire ant from shortest to longest. Let me go ahead and erase everything that we've done so far on our table. And they want the lengths of a housefly. So 1/4. Green June beetle, which is 3/4. So we already know 3/4 is bigger than 1/4. And the last one is the fire ant, which is 1/3. So I got 3/4, 1/3, and 1/4. Okay, let's do this again. 3/4, which is representative of the green June beetle. So I'm going to put that there. Fire ant, which is 1/3, or FA for fire ant. And housefly, which is 1/4. I'm just going to put HF for that. Now, I can easily compare the green June beetle and the housefly right off the bat because they are the same denominator. They have 4 at the bottom. This 1/3 I cannot compare as easily because it cannot become 4. It is not 4. So I'm going to do the same trick I did before, or you can call in previous knowledge. We know that 1/3 is bigger than 1/4, and we know that 3/4 is bigger than both of these. So right off the bat, we know that 1/4 is the smallest, then 1/3, then 3/4. That's be calling on previous knowledge since we've already compared these two earlier. Now, if you're not sure, or you want to be 1000% sure, what we can do is change these denominators so they're all the same. Again, 4 and 3's lowest common multiple is going to be 12. So I'm going to multiply all of these by 3, all of these by 4, and all of these by 3. Because 4 times 3 will equal 12. 3 times 4 over here will equal 12. And 4 times 3 will equal 12. I'm going to use a different color for each one of these now. So our green June beetle, probably should have used green for that. Let's undo that. Our green June beetle will be 3 times 3, 9/12. 9/12. Our fire ant will be 1 times 4, will be 4/12. And our housefly will be 1 times 3, 3/12. So going back to the problem, order the lengths of a housefly and green June beetle and fire ant from the shortest to the longest. The shortest one here, when we're looking at our new fractions is going to be the housefly at 3/12. I'm going to put the original fraction in, though. So I'm going to put 1/4 there. Then I'm going to put the next shortest, which is going to be this one right here, which is our 1/3. So I'm going to put 1/3 there. And our last one was our green June beetle at 3/4. Again, we're ignoring the new fractions. We only use those to compare. And I'm going to write 3/4. And that is my answer for number 4. Compare decimals and fractions. Positive and negative rational numbers can be represented on a number line. You can use a number line to help you compare and order rational numbers. Examples. Fill in each blank with, sorry, the alarm was going off, with either greater than, less than, or equal to make a true statement. These are going to be easy right off the bat. The very first thing you want to do is double check to see if any of them are negative. If they are, positive is always bigger. You don't even have to check the values. So 0.8, which is positive, is always going to be bigger than negative 1.2 because of the negative factor. And on a number line here, negative 1.2 is on the left of 0, and 0.8 is on the right of 0. Remember, whatever number's further to the right is the bigger number. Now, with example 2, both of them are negative, so I can't go on that alone. However, you are going to want to use the negative trick. Remember, the bigger the actual number is, the smaller it actually turns out to be. So this, let's ignore the negative 1 in front of it, and let's just compare the decimals because this is a negative 1 and this is also a negative 1, so they kind of cancel out. We're looking at the 40 and the 25. 40 is bigger than 25, but remember, when it comes to a negative scale, and this one's a vertical one, the further down or the further to the left it is, the less it is. Again, since it's negative, would you rather owe $40 or owe somebody $25? Negative 1.25 is the bigger number because it's closer to the right or closer to the top on a number line. Since negative 1.40 is down here, and negative 1.25 is up here in between negative 1.2 and 1.3. Negative 1.25 is the bigger number because, again, it is higher on the vertical number line. And if we were to put this on a horizontal number line, it'd be closer to the right than negative 1.40. Okay, and we have another one. Again, we identify that they're both negative, so I can't compare that way. And then we've talked about this earlier, comparing fractions. I'm going to go to my whiteboard. So this is negative 3/8. Comparing it, so I'm putting the circle there, to negative 5/16. Now remember, when we compare fractions, we want to make sure that the denominator is the same. I can turn 8 into 16 really easily. All I need to do is multiply it by 2. That becomes 16. And I have to do the same thing to my numerator, which would make 3/8 become 6/16. And remember, here's the deal. This is 6/16, and this is 5/15. And yes, our first inclination is, well, 6 is bigger than 5. Yes, but we have negative symbols in here. That's a game changer. So would you rather owe $6 or owe $5? So in this case, negative 5/16 is greater than negative 6/16. Again, I understand that 6 is bigger than 5, but both are negative. So remember, with negative, it's the opposite. You don't want, so again, like say it was negative 40 versus negative 2. Yes, 40 is bigger than 2, but since they're both negative, this is further away from 0 on the left, where 0 would be over here. You don't want to owe somebody $40, or would you rather owe them just $2? Negative 2 is bigger than negative 40 in this case. And the same thing will apply here with these fractions. Since negative 3/8 becomes negative 6/16 once we multiply it by 2 to compare with the same denominator of 16 here. Negative 5/16 compared to negative 6/16, negative 5/16 is bigger because, again, on a number line, negative 5, negative 6, 0's over here. Negative 5 is closer to 0 than negative 6 is. So negative 5 would be bigger. So they show you here, rename the fractions using the least common denominator. We multiplied by 2 to make it 6/16, comparing to negative 5/16. Since negative 6 is less than negative 5, then negative 5/16 is greater than negative 3/8, which is our original problem. So we do that. All right, and let's do our got it's. And then we are going to get into ordering for a little bit. We're going to do A and B on this one. A is real simple because we have a positive and a negative. So without even having to do any math work, positive is already bigger than the negative. Remember that shortcut. In this case, we have a negative 4.5 and a negative 4.49. We're going to go ahead and cross out what they have in common first. Give me 1 second. Sorry about that. So we are eliminating what they have in common, the negative and the 4. Negative and 4. Because they have this in common, we can already cancel out. If these numbers were different, we would be doing something completely different. Now we're just going to compare the 0.5 and the 0.49. Remember, 0.5 is the same thing as saying 50. 0.49 is 49. Remember, both are negative. So, would you rather owe $50 or $49? In this case, the negative 4.49 is greater than negative 4.5. Actually, we can do all of these really quickly. This one, both are positive, so we don't do the negative or positive thing, and both have the same common denominator. So we're just looking at numerators. In this case, 12 is greater than 9. And we're done. And in this case, both are negative, so we can't do the positive-negative trick, but we can do this. They do not have a common denominator, but I can easily make 5 into 10. I multiply this by 2. My new fraction will be 8 over 10, and remember, they're both negative. And remember, when they're both negative, it's going to go to the smaller number by default. Would you rather owe $7 or $8? So negative 7/10 is greater than negative 4/5. All right, and we're going to go through this a little quickly. Compare and order rational numbers. To compare and order rational numbers, we first write them in the same form. So again, when it comes to fractions and decimals, you're going to want to put them in either a fraction or a decimal. You do not want to keep them as both in order to compare. The easier thing to do is to convert a decimal into a fraction because you just go from left to right. This would be 51 and then the place value. So the first one is tenths. This is thousands. Sorry, tenths, hundredths. So this would be negative 51 over 100. And then you can simplify it down if needed. Or, like this says, you could always rename the decimal or the fraction as a decimal, then graph both decimals. Negative 8/15, and this is where I'm going to let you use a calculator. Remember, a fraction is just a division problem that hasn't been solved yet. 8 divided by 15 is the same thing as saying 0.533333 forever. So this would be 0.53 bar notation over the 3 compared to negative 0.51. Sometimes it's just going to be easier to convert the fraction down to a decimal, to be honest. And then we are going to compare them. Since they're both negative, negative 0.53 would be on this side, negative 0.15 would be on this side. Remember, the number closest to 0 is the bigger number. Therefore, my answer is negative 0.51 is the greater number. Since 0.51 is to the right of negative 0.53 with the bar notation over the 3 on a number line, negative 0.51 is greater than negative 8/15. Now we're going to order the set. All of these are negative, so the first thing you want to do is when you're ordering a set is divide the negatives and the positives away from each other, because you know what's going to be, greater or less. This wants us to order it from least to greatest, so we need to figure out which one of these is the smallest. We're going to write negative 222 over 25 and negative 2 1/10 as decimals to the hundreds place. If we were to divide 22 by 25, that would equal 0.88, which is what they put right there. So this becomes negative 2.88. 1/10 when divided will become literally 1 in the 10th place. So we don't have to divide that. It'll become negative 2.1. Our other number is already a decimal, negative 2.46. So let me rechange what I said. You can easily turn a decimal into a fraction. Doesn't mean it's going to be easy to compare. I don't know why I said that. Always go with turning a fraction into a decimal, because then you don't have to have a common denominator to compare them. When you turn a fraction into a decimal, you can just compare decimals. So the easier method is to turn any fractions into decimals. So I have negative 2.46, which is graphed right here. And remember, closer to the right is 0. Negative 2.1 is graphed right here, because remember, 0.1 is smaller than 0.4, so it's going to go this way on a number line, but remember, this is still technically greater than it. And then negative 2.88 would be over here. We want from least to greatest. The further to the right, the lower it gets, so it's already in least to greatest for us. Negative 2.88, which originally was negative 2 22/25, which is right here. So that's our first one. You always want to rewrite it in the original fashion. Then negative 2.46, which is already negative 2.46. And then negative 2.1, which was originally 2 1/10, which is right there. And that's it for this lesson. As far as homework goes, you guys are responsible for all 18 questions. If you guys have any questions, please feel free to message me. As always, I'm Mr. P, and I'll see you guys on the next one.